Circles are an example of one type of conic section. And as we talk about how to come up with the equation of a circle and how to graph a circle, two formulas from Math 171 are going to be important for us to review. And those are the distance and the midpoint formulas. Here you see the distance formula. Generally, we would say we subtract the x's and square that, subtract the y's and square that answer, add those together and take the square root. And the distance formula is really nothing but the Pythagorean theorem. Then we also have the midpoint formula, and this is how you can find the middle of a line segment. So we've got the same 2 points. We add the x's and divide by 2, add the y's and divide by 2. So if we have this task, we are asked to find the center and the radius of a circle that has a diameter within points at -4, 3 and -1, 7. Well, the center of the circle will be at the midpoint of the diameter. So we'll use our midpoint formula. Add the x's, divide by 2, add the y's, divide by 2. So our center of our circle is at -5/2, 5. The radius of a circle is the distance from the center to any point on the outside of the circle. So we find the distance between -5/2, 5, and either one of these 2 points. The point that I chose was the point -1, 7. So employing the distance formula, we have the square root of x minus x, so -1 minus -5/2, plus squared, plus y minus y, 7 minus 5 squared. We work this out and we see that we get the result 5/2. So the radius of the circle is 5/2. Now I think it's interesting to notice, and please note that there was an error on your notes and you'll want to change this. This equation in standard form, and we'll talk more about standard form shortly, is given by x plus 5, 5/2, quantity squared, plus y minus 5, quantity squared, equals 25/4. I want to point out where some pieces of information, here the center and here the radius, can be found in this equation. Notice 5 is the y value of our center, and y minus 5, quantity squared, is involved in our equation. -5/2 is the x portion of our center. +5/2 is contained in x plus 5/2 quantity squared. So in each case, it's the opposite sign that we had back here. And then, and it's a bit coincidental and perhaps unfortunate that we had 5/2 as a radius, but where that appears is here. So this is our radius squared. So when we know the center of our circle, and oftentimes we'll refer to that as HK, and the radius of our circle, which we would refer to as R, we can use these pieces of information to come up with the equation. Let's take a look at another example. Let's say that we want to find an equation for points a distance of 3 away from the point -1, 2. So we'll plot this point at -1, 2. Okay, so an equation, I tell you here that it's a circle, but we don't see it in these instructions. But think about it, everything that's 3 away from the point -1, 2 is going to be a circle. So we would go up 3, 1, 2, 3, down 3, right 3, left 3, to be able to kind of visualize what we're finding here. We are sketching, an important word when we are drawing our conic sections, because they're not going to be perfect. So what we're really being asked to find is a circle whose center is -1, 2, and whose radius, since all these points are 3 away, then our radius is equal to 3. Well, let's think of it though for right now in terms of the distance formula. We know the distance is 3. So we recall our distance formula. D is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Okay, so let's call this point x sub 2, y sub 2. Okay, and we have this center at the point negative 1, 2. Let's find the distance between these 2 points. So our distance, which we know is 3, 3 is the distance between these two, is equal to the square root of x sub 2 minus, remember this is the point negative 1, 2, negative 1 quantity squared, plus y sub 2 minus 2 quantity squared. I'm going to drop off the sub 2 because we really, excuse me, don't need that. We've got x plus 1 quantity squared plus y minus 2 quantity squared. This is an equation for this situation that we were trying to create an equation for, but we don't always like to have that square root on there. It's a little cumbersome. So we can square both sides, and when we do, we get 9 is equal to x plus 1 quantity squared plus y minus 2 quantity squared. And just to get it in an even more typical setting, we'll put the variables on the left and the constant on the right. Again, notice that our radius is 3 and our equation is equal to our radius squared. Our center, the x part was negative 1, and in our x binomial we have x plus 1, and that's quantity squared. Our y part of our center is 2, and we have y minus 2 squared. What this leads us to is how we can find the standard form of an equation of a circle. And it is developed from the distance formula. So hopefully this makes a little bit of a connection for you, but here is the main takeaway from this. A circle with radius r and center at hk has the equation x minus h quantity squared plus y minus k quantity squared is equal to r squared. So when we are given the equation of a circle, we're able, when it's in standard form, we are able to quickly identify the pieces of information that will help us graph this circle. So the center of the circle is 4, negative 3, because that's like y minus negative 3 to be able to get that plus. A way I usually just like to think of it is it's the opposite of what this looks like. It looks like negative 4, 3. It's really 4, negative 3. The radius is the square root of this number. Okay, so our radius is the square root of 12, which is 2 square root of 3, which is about a little bit more than 3. A tiny bit more than 3. So for our center, we'll go to 1, 2, 3, 4, negative 1, 2, 3. And from here, we will go up 1, 2, 3, and a little bit more. Left 1, 2, 3, and a little bit more. Down 1, 2, 3, and a little bit more. And right 1, 2, 3, and a little bit more. And we will sketch in our circle.